Example 2. Still some relative velocity stuff. Let's draw our river again. Okay, we still have a river flowing at about 4 meters per second. How fast is that in miles per hour if you do the quick conversion? 8. Yeah. Now that's off. That's not exact. That's just a good estimation. Okay, now our boat this time has a 6 meter per second capability. That probably means that it's got a little motor on it. Okay, you can't really row at 6 meters per second. Okay, that's pretty beastly. Okay, probably a little motor going on there. What velocity vector would the boat need to make it directly across the river with no drift? So they want to go directly across. They can't travel downstream at all. In the rafting world, there's a rafting term for this. Anybody? Okay, it's called ferrying. That's going to be on the AP test, by the way. Okay, ferrying. All right, you talk about ferry angles. Okay, that's what we're solving for. We're solving for a ferrying vector. Okay, now, what direction is the boat going to have to point? Just from common sense. It's going to have to point upstream to cancel out that 4 meters per second. In fact, the x side of our triangle has to be 4 to cancel out the river. Okay, so we're going to go down here and we're going to draw a triangle, and this is going to be a quick problem. Okay, so here's what we want. We've got 4 meters per second this way. All right, we are going to draw our resultant vector. I'm going to use red for that. So we're kind of doing this backwards from how we've done the last 2 triangles we drew. Okay, that's what we want our resultant to be. We know that the x side of our resultant vector has to cancel that out. Okay, now this is where we're going to go. Well, I kind of messed that up a little bit. I got to add a little. Okay, we are going to go like this. Okay, values. Here's 4. Here's 6. Okay, and now we just have to solve for this side. So let's look at the Pythagorean theorem. A squared plus b squared equals c squared. Okay, and let's call this b. Alright, you guys are already punching it into your calculators. You know what to do. Okay, so we got 4 squared plus b squared equals 6 squared. Decided to go with the plug and chug method there. And so what we're going to do is we're going to say that b squared is equal to 36 minus 16. And then we just have to square root both sides. Okay, let's figure it out. Okay, looks reasonable. Okay, so this is the velocity it's going to look like it is going as it's going across. All right. The boat is actually going to have this velocity though. So it's actually going to be going 6 meters per second with respect to the water. All right. Now this angle here, let's go and find that angle. Okay, we're going to call this theta. And we could have found that angle without finding this, by the way. Okay, so we'll say tangent theta is equal to our opposite, which is 4, over our adjacent, which is 4.47. We got to do inverse tangent in our calculator. Okay, and we get 41.8 degrees. Okay, so our heading for no drift, if we don't want to get any drift, okay, here's kind of our final answer. We're going to get 6 meters per second at, what we're going to do to keep this from 0 is we're going to have to do what? Okay, because here's 0. So what are we going to have to do to give our final angle? We're going to have to add 90, so plus 90 to our answer. We get 131.8 degrees. Okay, so that's our heading. Okay, this is the speed that the boat is actually going to be going, okay, with respect to the land. So if there's an observer at the land, it's going to look like they're going 4.47 meters per second. All right, those are common things you'll get asked with two-dimensional vector problems like this with rivers. Also applies to airplanes. You're going to see airplanes on your WebAssign. Okay, so instead of water, what are we dealing with? We just got air. Okay, we got wind.